This is the first episode of my tutorial about the large-scale React applications, and in this video we will break down one of the most crucial and often controversial foundations of any large React codebase: how you organize your folders and files, structure your repos, and enable code sharing among different teams and applications. Whether you're starting fresh or inherit a big project, these decisions directly influence your team velocity and the project maintainability. So let's start. Let's face it, a good project structure is a lifesaver for onboarding new devs, keeping complicated parts from getting tangled up, and making it clear who owns what. If your setup is a mess, you will end up with a smelly code, random undocumented knowledge, and silly bugs that waste everyone's time and company's money. And as your team and project evolve, the code structure should change with them. But the right start early on could save you a lot of pain in future. How should you organize your folders? There are few strategies you usually meet. The first one is a classic way, horizontal or so-called layered approach. This is a by-type structure that everybody's seen, let's say, in the Create React app. You have separate folders for your components, for your stores, styles, utils, hooks, and etc. And it is simple, it feels comfy for tiny projects. But one day you may find yourself with a huge God folder that has 200 files and no one owns them. So yes, this structure works for small applications, but do not try to scale with it. So what are the alternatives? The first one is the domain-driven structure. This is all about business logic. You get separate folders for each business area. So let's say if you've got e-commerce website, then you may have folder for checkout, user, catalog, and etc. And everything that is related to a certain domain is in one place: state, UI, hooks, and APIs. It helps to keep the ownership clear and good for the domain-focused teams. So if your app has a bunch of different sections and few teams working on them, then you may want to consider this structure. And another one is feature-based or vertical slicing, and this is about user-facing features. Each feature has its own folder, and it makes it easy to split up and work on these features separately. What's the difference between this and domain structure? Well, domains are usually bigger than features, and sometimes you may want to use some kind of a hybrid approach. And when you find yourself copy-pasting the same code in 5 different folders, then it makes sense to extract it into a shared folder or a package. And yes, many of the real-life projects do not follow just one of these structures, they mix it up. So use domain or feature-based approach for most of the things and create shared folders for the common code. But if the folder starts getting giant, then it is a sign that you have to split it up again. Now let's zoom one level up and talk about repositories. Single repo or a bunch of them? Well, that actually matters a lot. The first approach, Monorepo, is when all of your apps, libraries, packages, functions, whatever, lives under the one roof in the same repository. And it might look like this. And with this approach you can make changes and share code easily, you can use the same CI/CD pipeline and avoid the versioning hell. But yes, there are some downsides as well. On the huge teams there can be some tooling slowdown. And moving from a multi-repo approach to a monorepo could take a little bit of planning, but usually it pays off. And a multi-repo or microservices approach is when each of your applications or features live in a separate repository and has its own pipelines, deploy strategies, versioning, basically anything. This is good if you need a strict separation for, let's say, security reasons, or you want to make a part of your code base open source, or sometimes teams just prefer to work in isolation. But cross-cutting changes get hard with this approach. Keeping dependencies updated, doing integration tests, and dealing with the versioning can be hard. But again, in the real-life project, you don't have to follow just one of these approaches. People often use a hybrid approach. They keep shared code in one big monorepo and use a separate microservices for things like confidential features or region-specific projects or some self-contained APIs and applications. And the best setup really depends on the company size, on the kind of work, and also the compliance requirements you need to follow. And if with microservices it's all more or less clear, monorepos usually require some special tools to make it easier to deal with. So let's take a quick look at these tools that might be helpful if you decide to use monorepos. And the first of them is Yarn Workspaces. This is a built-in Yarn feature, and it's great for linking packages, deduping dependencies, and really easy to start with. Another one is Anix. This is the powerhouse of monorepos. It can track what depends on what, caches builds and tests, and even can enforce things like don't import outside from this domain. And next, Turborepo. It is blazing fast and really great for modern JavaScript and TypeScript. Very easy to configure your CI pipelines, and very little config is needed to start with it. And Lerna has been around for a while. It is mostly used for versioning and publishing, together with the Yarn Workspaces. But these days, Anix and Turborepo take over on the modern projects. And another useful package is ChangeSets. It handles changelogs and semantic versioning for your apps, and it is often used alongside with all these fancy monorepo tools. And let me know in the comments below if you want to know more about all these tools, and I can make another video to talk about it more in depth. Now let's talk a little bit more about code sharing in monorepos. How does it happen exactly? So everything that might be reused in monorepos becomes an npm or yarn package. It has its own folder in the packages directory and its own package.json and all kind of utility files and configs. Your UI kits, shared hooks, analytics, it all can be a separate package. And then you can use a workspace notation to link your packages locally for instant updates. And if you want to split into public and private packages, you can use an internal registry. And what's very important for the code sharing is to always write a clear APIs, document your stuff, and automate the versioning. And now we are almost at the end of this video, and let's quickly overview our best practices for code structuring. First of all, never create a God folder. If it feels crowded, split it up. Always set clear boundaries. You can use Anix for it, or even just ESLint to prevent unwanted modules and circular dependencies. Automate your code structure. Use scaffolding utilities and code generators to keep things consistent when you create a new feature. Make ownership obvious. Always tag which team owns domain or a package. Always track changes. Use changelog to keep it up to date. And make sure every new package or pattern has its docs or ADRs to make an onboarding easier for new developers. And now let's talk about code organization anti-patterns. And as I already said, dumping everything into one or two folders, this is a big no. Too many layers of abstraction is also not good. Don't over-engineer your application before it is needed. Do not copy-paste. Instead, extract your logic and make it shared. But don't let the shared folder to turn into a junk bin. Modularize, document, and keep boundaries. Yes, code organization may sound as a lot of work, but it is a backbone of a scalable and healthy React application. Figure this stuff out in the beginning and save yourself a lot of suffering after. And that's it for today. I hope it was useful for you, and don't forget to like this video and subscribe for more episodes. See you soon!